before I start, sorry, it's taking some time to, okay. So this is an overview of my presentation. I'll start with introducing the topic and the relevance of the topic, and then I'll talk about the research questions and the research methodology that I have adopted to answer these research questions, and then I'll talk about the findings. The findings are subdivided into three parts: data management challenges, data ops and data pipelines, and modeling data pipelines. So these three parts of the findings are based on the 5 empirical works that I have already done and published. And then before moving to the conclusion, I'll summarize the whole research process and the results obtained from this research. And finally, I'll conclude my seminar with the future directions that I would like to explore after my licentiate. So to set some context, we all know that data is a revolution that has the capability to transform our life, work, and even thoughts. So increased data volume, data variety, data velocity, and the impact of poor quality data are some of the significant challenges that are encountered by the practitioners from the industries. This data management can help to increase the productivity, reduce data loss, and improve data quality. And it also enables accessibility and availability of data. And we know that now AI has evolved as a horizontal technology, and data is the backbone of it. So this also adds the importance of data management. So when I say AI has now evolved as a horizontal technology, I mean that AI components are increasingly being integrated into the embedded systems along with electronics and software. So these systems that involve both traditional software components as well as AI components are referred as AI-enhanced embedded systems. So this is a new term that we are introducing now. You might not have heard this before, but in the upcoming slides, you will hear a lot more about this AI-enhanced embedded systems. So why do we need to incorporate these AI components in embedded systems? So these AI components are used to enhance the existing functionalities. For example, our mobile phones with AI camera. These AI cameras enable us to capture spectacular images, which doesn't mean that this mobile phone is an example of AI-enhanced embedded system, but not an AI-enabled system. Because in this AI-enhanced embedded systems, only a particular functionality or a set of functionalities are enhanced with AI components. So now moving on to the relevance of the study. So before starting my PhD officially, I was participated in another research with Lucy Ellen in the same team, where we studied the software engineering challenges for machine learning and deep learning systems, which gave me the intuition of the significance of the data and why so data was one of the prominent challenges that were holding the companies back from attaining the full AI and data potential. Moreover, the pictures that you see now on the screen are from 2 papers, one published by Google and the other from Microsoft. In both, you can see that the data collection, data verification, data cleaning, and data labeling has got a significant importance. And they comes as a very early stage of the data pipeline or the framework, which indicates that data has a strong impact on the development of machine learning and AI models in general. So our motivation was that there are several studies that are already published and from industries shows that data management is a challenge faced by the AI practitioners. And AI models raise unique data challenges such as overfitting, data drifts, class imbalance, data granularity, etc. So data being the backbone of AI models, data errors can cause severe performance degradation. Moreover, these data steps are coming as a very early stage in the AI pipeline. So what happens is that the errors in those stages will get propagated to the successive stages, and finally, the performance of the model will get affected. So our goal is to improve the existing data management approach that can be used for building and maintaining high quality data products, including AI models. So we have subdivided this goal into 3 objectives. The first one is to empirically identify the data management challenges encountered during the development and maintenance of AI-enhanced embedded systems. And the second one is to propose and implement an improved data management approach. And the third is to empirically validate the proposed approach. So in order to fulfill those objectives, we have formulated 3 research questions. The first one is, what are the challenges associated with data management in embedded system companies? And the second is, how can practices such as data ops and data pipelines help address data management challenges? And the third is, what implications does AI have on data management? And what practices can help address the development and maintenance of AI-enhanced embedded systems? So in order to address 3 research questions, we have adopted a qualitative research methodology. So qualitative research methodology actually enabled us to get answer for questions about experience, meaning, and perspective from the standpoint of a participant who was an industrial expert. And it also enabled us to capture real-life experiences, which varies from one person to another. Of course, the challenges and industrial practices cannot be always counted and measured. So qualitative research methodology is the best suited for doing this kind of research. And the knowledge gained from qualitative research methods can inform industrial practice, what is required by the practitioners, and indicate how to better support industrial data management challenges. And coming to the research methods that we have adopted for doing this study, we have used 2 research methods. The first one is interpretive multiple case study, and the second is action research. So the interpretive multiple case study was primarily done for exploratory purposes. For instance, when I wanted to identify the data management challenges and also the data pipeline management challenges, I've used this interpretive multiple case study. And it allowed me to capture the real-world complexities of data management in the embedded system company scenario. And I have used 2 research techniques here. And the first one is semi-structured interview to explore the perceptions and opinions of respondents. And it also enabled me to probe for more information and clarification for the answers that the practitioners have already given. And it also helped me to establish a sense of rapport between the respondents and myself. And the second research technique that I adopted was participant observation, because in the same time I was working as an action researcher in 2 of the case companies. So it allowed me to participate in the weekly meetings and the stand-up calls, etc. So participant observation or an unstructured observation was kind of easy while I was attending those meetings and stand-up calls. And so our objective was not only to explore and identify different challenges, but also to implement and validate the solution approach. That is why I've chosen the action research as another research method. So action research enables or gives an opportunity to work collaboratively with problem owners at the organization, and it also allows to propose, implement, and evaluate the solution in real time. And the participatory aspect of action research allowed me to systematically determine and define the problem with data management practices and make a solution proposal in the context of an investigation. And it also allowed to actively participate in the further steps of applying the solution in real time, which is termed as action. In this action process, 2 other people from the company also joined me to implement the solution that I have proposed. And moving on to the findings of my research. So as I told you in the beginning, the findings are subdivided into 3 parts. And the first part is data management challenges, which is related to the first research question, that is, what are the challenges associated with the data management in embedded system companies? So here our objective was to identify the data management challenges encountered by practitioners due to the recent AI advancements, for which I have used an interpretive multiple case study approach, in which I did semi-structured interviews with 8 experts from 6 case companies. And these are the findings that we have obtained from that study. So we have identified 20 data management challenges and from 6 different use cases and I have mapped these challenges with the use cases in which they appear. So the use cases were a recommender system, a wind power prediction system, a house price prediction system, a medical diagnostic system, a financial fraud detection system, and manufacturing system. I'm not going into the details of these challenges, but we have mapped these challenges according to the phase in which they appear in the data lifecycle. So yeah, these are the remaining challenges. And moving on to the second part of my research, which is data ops and data pipelines, which is related to the second research question, that is, how can practices such as data ops and data pipelines help address data management challenges? And our objective here was to explore industrial data management practices at embedded system companies to adapt to the increasing significance of data. We have adopted interpretive multiple case study to do this research with 14 use cases. And I have conducted semi-structured interviews with 32 practitioners from 4 case companies. Moreover, I have also used multivocal literature review as a research technique because the peer-reviewed literature on data ops was very limited. We have only got one paper, if I remember correctly. So we have used the Google links as well as the peer-reviewed literature for doing this multivocal literature review. So before going into the details of how data ops is helping for data management in industries, let's see what is data ops. So data ops can be defined as an approach that accelerates the delivery of high quality results by automation and orchestration of data lifecycle stages. Data ops adopts the best practices, processes, tools, and technologies from agile software engineering and DevOps for governing analytics development, optimizing code verification, building and delivering new analytics, thereby promoting the culture of collaboration and continuous improvement. So this is a definition that we have created based on the multivocal literature review and multiple case study. Now, let's see how the data ops can help in the data management. It can reduce the end-to-end cycle time of data analytics from the origin of ideas to the production of insights. Data lifecycle has an intersection between two data pipelines, namely value pipeline and innovation pipeline. Value pipeline is the traditional pipeline which creates insights from the data, and innovation pipeline is for injecting new analytic ideas into the value pipeline. It introduces, like the data ops introduces agile development into data analytics and allows data teams and users to work together. And it adopts DevOps principles to manage artifacts like data, metadata, and code. And there are certain components in data ops that helps to manage data in the industries. And they are value pipeline, innovation pipeline, test cases, continuous monitoring, alerting mechanism, and mitigation strategies. So this value pipeline helps to collect real-time data from multiple sources, ingest them, extract, transform, validate, and publish the insights. And innovation pipeline helps to deliver insights to the customers every third week, collects feedback from them, and do the rework if it is required. So the companies that I have worked with, they were doing this delivery of the insights every third week, but this might differ for different companies. And there will be also test cases for testing the quality of data flowing through the pipeline. And there will be also continuous monitoring, which is an automated mechanism. And there will be also alerting mechanism, which is automatic. And simply identifying the faults will not serve the purpose. So this data ops will also have mitigation strategies to handle this pipeline breakage. So we have already seen that data pipeline is a critical component for implementing data ops. So our next study was based on data pipelines. Data pipelines are nothing but a complex chain of interconnected activities that starts with a data source and ends in a data sink. And it can process data in multiple formats from distributed data sources with minimal human intervention, accelerate data lifecycle activities, and enhance productivity in data-driven enterprises. So fault in a single step of a data pipeline has cascading effects and can lead to significant performance degradation in data-intensive systems. Therefore, we would need continuous monitoring and fault detection mechanism. So you have already seen some of the opportunities with data pipelines, but then these are some more opportunities, like it can help to solve data accessibility challenges. It saves time and effort of human resources. It improves the traceability of data workflow. It supports heterogeneous data sources. It accelerates data lifecycle activities. It can standardize the data workflow. It can help to improve data analytics and machine learning models. It enables data sharing between teams, and also it's a critical element for data ops. Besides finding these opportunities, we have also found out some challenges, and we have categorized it into organizational, data quality, and infrastructural challenges, which you can see in this slide, but I'm not going into the details of it. And moving on to the third part of my research, which is modeling data pipelines, it's related to the third research question, that is, what implications does AI have on data management and what practices can help address the development and maintenance of AI-enhanced embedded systems? So our objective here was to identify the impact of improved data management practice on delivering better quality data products. And also we investigated how the improved data management practice helped companies to accomplish automation. I have adopted action research for doing this research, and the action research was done in 2 companies. And this is a result of the conceptual model for data pipeline. So based on the action research, we have developed this conceptual model. There are 2 basic elements for this conceptual model for data pipelines, and they are nodes and connectors. Nodes are nothing but the blue boxes that you see in the screen right now, and the arrows that connect those blue boxes are called as connectors. So we have 2 different capabilities assigned to the different elements in the data pipelines here, and they are node level capabilities and connector level capabilities. For instance, the data generation, data collection, data storage, data ingestion, data extraction, data labeling, all these are node level capabilities, and sending alarm, authentication, validation, fault detection, mitigation, etc. are some of the connector level capabilities. So in the first circle, you can see different data sources that produces data. So in all the companies that I have worked with, these were the different sources that were generating or producing data. There can be many other sources for data. So some of them I have listed already here. And once the data is generated, it is collected. So this data generation mostly happens in the customer premises or the client location. So there will be a data collection agent to collect the data from this data sources. And this data collection agent has to authenticate itself before collecting the data from the data sources. And then this raw data is stored in a raw data storage, from where it is taken, from where it is ingested into the data pipeline, and then data extraction is done according to the use case. And most of the companies were using supervised machine learning models. So therefore, they need to label the data for that. So they do the data labeling, and then the label the data stored in a refined data storage, from where it is taken and given as input to the machine learning or deep learning models. And then a model evaluation is done, and once satisfactory performance is obtained, the model is served, and once it becomes operational, this model will again generate data, and thus it will become a data source. So there can be different faults in different stages of this data pipeline. In order to identify these faults, we have something called fault detection that is marked as a connector level capability in each of the different stages of the data pipeline. Simply identifying the faults or detecting the faults will not serve the purpose. So we have something called mitigation strategy that will help to prevent this data pipeline breakage. So whenever a fault is detected, a corresponding mitigation strategy is called, so that the effect or impact of this fault or failure will be minimized. And then we have something called sending alarm, which is adopted by most of the companies as a default mitigation strategy. Because even if we have this mitigation strategy, it will not completely solve the problem, but instead it will only ameliorate the effect or impact of the problem. So we have something called sending alarms, which will send alarm to the corresponding department or the concerned staff, who will take care of the fault and will fix it. So moving on to the automated data pipeline recovery, we have already identified typical faults in a data pipeline and corresponding mitigation strategies. I don't think I'll get enough time to go into the details of these. So it's already published as a paper. So if anyone is interested, you can just ask me and I'll give you the details. So in order to do this automated data pipeline recovery, there are 2 connector level components in the data pipeline. They are fault detection and mitigation. So incorporating these new components in all links was certainly not achievable within a short period of time due to the practical difficulties. So we have chosen a small slice of data pipeline. Moreover, the companies, the data pipeline in which I was working on, it was already operational. So the company don't want to take a risk by allowing us to implement this fault detection and mitigation at each stage of the data pipeline. So we have chosen a small slice of one of the data pipelines that I have worked with. And this is that particular data pipeline. So it has data generation, data ingestion, data storage, and data application as different nodes. And then so this data pipeline is basically spread across three different zones: Zone A, Zone B, and Zone C. Zone B is where I have worked. Zone A is place where the data is generated. So this particular data pipeline was collecting data from different teams in the same company, and also which is called continuous integration data. And they also collect data from the devices that are deployed in the customer premises, which is termed as continuous deployment data. So these data is ingested into the data pipeline, and sometimes there can be encrypted data links. So these encrypted data links are sent to the data archiver, which will again send it to another third-party service, which is located in Zone C, that is completely out of this company. And they will do this decryption and send back this decrypted link back to the data archiver, and the data archiver stores this in a central data repository from where different data applications can access data and do or create reports or whatever they want to do with it. So, due to inadequate bandwidth or insufficient resources, these third-party services sometimes fail to decrypt the data links that are sent to them. And so these data dumps will be completely missing, and it will not be stored in the central data repository. And this affects the data application, so which fetches the data from the central data repository. So we decided to implement a fault detection and mitigation strategy in between these two nodes, that is data archiver and third-party service. So we implemented a fault detection and mitigation strategy over there. And after implementing the fault detection mechanism in between these two nodes, we found that there were failed dump IDs of 32,453 over 30 days, which constituted 37% of the total dump IDs. So the quality of reports were significantly affected. And we employed a mitigation strategy over there, which is failed dumps are automatically resent as small batches along with the new dumps to the third-party services. So at some point of time, these links or these data dumps will be decrypted and sent to the data archiver, which will be stored in the central data repository, and thus we can save a lot of missing data dumps. So to summarize, these were our three research questions. Like the first one was, what are the challenges associated with data management in embedded system companies? I have adopted exploratory case study for doing this, study. And then this was done in case company A. And the results we obtained was we identified data management challenges and classified it according to the phases in the data lifecycle. And the second research question was, how can practices such as data ops and data pipelines can help address data management challenges? So we used exploratory case study and action research, and the case companies where I did this was B, C, D, and E. All companies wanted to remain anonymous. That is why I have named as A, B, C, D, and E. And we have already identified opportunities of data ops, the challenges for the adoption of data ops. We have also identified opportunities and challenges with data pipeline management. And the third research question is, what implications does AI have on data management, and what practices can help address the development and maintenance of AI-enhanced embedded systems? So we have used, again, action research here, and the action research was done at two companies, B and D. And we implemented a conceptual data pipeline model on operational data pipeline at company B and analyzed the impact of the improved data management practice. But then I also proposed a conceptual data pipeline model for an operational data pipeline at company D as well. But unfortunately, we did not get approval, as that data pipeline was in turn dependent upon another data pipeline, which was completely out of this particular company. So we were not able to do that at company D, but at least I got the approval from the steering committee, etc. So moving on to the conclusions, we already seen that data management is essential to successfully deploy AI-enhanced embedded systems, and data pipeline is a good practice for data management. And the proposed conceptual model for data pipelines maximizes automation and minimizes human intervention. To maximize automation, we have had a fault detection component as well as a mitigation strategy. So as soon as the fault is detected by the fault detection component, it will invoke its corresponding mitigation strategy and also send an alarm to the corresponding team. So sending alarms is a default mitigation strategy that is adopted by almost all the companies that I've worked with. Okay, so now moving on to the future work. So as I told in the findings part, we have already identified a huge list of typical faults that can occur in a data pipeline. And we have classified it according to the different stages of the data pipeline. And we have also found out the mitigation strategies whenever those kind of faults are detected. But then that list is not exhaustive. So now, as a future work, I want to develop an end-to-end data pipeline with a fault detection component, which does automated fault detection and mitigation. That is like I'm planning to give some sort of intelligence to each and every component of the data pipeline so that the faults will be automatically detected and mitigated. This entire presentation is based on this 5 papers, except for the motivation slide, so all these papers are published, and I'm the first author for these 5 papers. Okay, so thank you all for your kind attention.